On December 7, 1941, as flames consumed the battleships at Pearl Harbor and America gasped at the unthinkable, a radio transmission crackled into a sparse office at Fort Meade, Maryland. Lieutenant Colonel Andrew D. Bruce sat surrounded by manila folders detailing a nightmare that had been unfolding across North Africa for months. The reports painted a picture of armored dominance so complete it seemed unstoppable. British Matilda tanks reduced to burning wreckage in the desert sand. American Stuart light tanks twisted into scrap metal by German 88mm guns. Each report told the same terrible story. German panzers were slaughtering American armor with brutal efficiency, and nobody seemed to know how to stop them. While Bruce wrestled with these tactical horrors hundreds of miles away, a man stood in a Detroit design studio gazing out across the industrial landscape that had made America an automotive superpower. Harley Earl was 48 years old, and his wire-rimmed glasses reflected the sprawl of General Motors' technical center below him. He commanded the respect of engineers and designers through an almost mystical blend of artistic vision and intuitive understanding of motion and form. His hands never stayed still, constantly sketching invisible designs in the air, fingers tracing the flowing lines that had revolutionized how Americans thought about automobiles. Then came the telephone call that would change everything. William Hudson's voice on the other end carried an unmistakable weight of urgency. The War Department had an impossible request. They needed something that didn't exist in the arsenal of American armored warfare, a machine that could race across battlefields faster than German panzers while packing enough firepower to pierce their armor. They wanted Buick to build it. Earl assembled his design team in the studio's main hall, clearing drawing boards that had once held sketches of chrome dreams and flowing fender lines. These weren't just engineers, they were artists accustomed to thinking about beauty and motion, men who understood that a vehicle's power lived in its form and silhouette. Steve McDaniel, Earl's interior design chief, methodically arranged technical specifications alongside artistic renderings, his craftsman's attention to detail creating a bridge between Earl's wild vision and the cold mathematics of engineering reality. The early sketches showed promise. Sleek and low-slung, these vehicles looked more like race cars than the brutal, angular machines emerging from European factories. Earl could feel the momentum building, the creative electricity that always accompanied breakthrough thinking. Then the Army engineers delivered the crushing blow that shattered his initial optimism. German Panzer IV tanks carried 3.1 inches of frontal armor, capable of withstanding every gun in the American arsenal. Intelligence reports from North Africa described tactics so sophisticated and coordinated that Allied forces found themselves consistently outmaneuvered despite numerical superiority. The military brass made their demands crystal clear: thicker armor, more steel, build fortresses on tracks that could absorb punishment and keep fighting. Earl stared at the requirement sheets, his pencil tracing patterns on the margins. The laws of physics were unyielding and merciless. Heavy armor, powerful gun, high speed, pick two. That was the cruel equation that had governed armored vehicle design for decades. Traditional military thinking screamed for bigger, heavier, more massively armored machines that could stand toe-to-toe with enemy panzers. Build bigger guns, add more steel, outmuscle the opposition. But Earl's mind worked differently. His artistic sensibility allowed him to see beyond conventional wisdom toward possibilities that straightforward military engineers couldn't imagine. Personal stakes weighed on every decision he made. Somewhere in the Pacific, his own son served as a Navy pilot, fighting Japanese Zeros with nothing but speed and agility to keep him alive. This wasn't theoretical engineering anymore. This was about bringing American boys home alive. The photographs on his desk, young faces in uniform, haunted him constantly. Every design choice could mean the difference between families receiving letters of commendation or telegrams of condolence. As 1942 dawned, Buick's production lines fell silent. The company that had built America's luxury automobiles converted entirely to wartime manufacturing. Skilled craftsmen retooled from chrome and comfort to steel and survival. Earl faced the biggest gamble of his entire career, knowing his reputation and the lives of countless American servicemen hung in the balance. Then the impossible decision crystallized in his mind with stunning clarity. What if he stopped thinking like a conventional tank destroyer designer? What if he rejected every principle that military doctrine had established over decades? Instead of building a tank destroyer that could absorb punishment, he would create one that would never get hit in the first place. Maximum armor thickness, just 1 inch. Total weight, 20 tons instead of the typical 30 to 35 tons. The concept violated every fundamental principle of armored vehicle design. It challenged generations of military doctrine with an idea so radical that Earl's own engineers questioned his sanity. Men who had spent careers building increasingly heavy vehicles stared at these specifications in disbelief. But Earl understood something they didn't. Speed could be armor, maneuverability could be protection. American industrial might could produce precision rather than bulk. Instead of machines that absorbed enemy fire through sheer thickness, he would create vehicles that danced around that fire entirely. He was fundamentally transforming the equation of armored warfare itself, from survival through strength to survival through swiftness. In March 1942, unseasonably cold winds swept through Detroit as Earl's design team gathered around the clay mock-up that would either vindicate or destroy his revolutionary concept. The sleek profile bore absolutely no resemblance to existing American armor. Its low silhouette and flowing lines looked more like a land-bound torpedo than a conventional tank destroyer. Earl moved his hands across the clay surface with the same reverence he'd shown automotive masterpieces. But his eyes betrayed the weight of knowing this design would face 88mm anti-tank guns instead of suburban highways. When Earl announced the armor thickness decision to the assembled engineers, the room fell silent. 1 inch. Barely enough to stop rifle bullets, let alone anti-tank rounds. Men who had devoted their careers to building increasingly bulletproof vehicles struggled to comprehend armor so thin it could be penetrated by machine gun fire. Steve McDaniel's methodical mind raced through calculations, finally understanding that Earl was betting everything on a single principle. What couldn't be caught couldn't be killed. Earl's engineering team pushed technological boundaries relentlessly. The torsion bar suspension system they developed provided stability at speeds no armored vehicle had attempted before. Each component was individually tuned to handle brutal combat maneuvering while maintaining the smooth ride that allowed accurate gunnery at maximum velocity. The transmission and differential underwent complete redesign to handle power outputs that exceeded anything from Earl's automotive background. The engine itself became the heart of Earl's revolution, the Continental R975 radial aircraft engine. This 400-horsepower, 16-liter monster had been designed to power B-25 Mitchell bombers through European skies. Its air-cooled design eliminated vulnerable radiator systems that made conventional tanks sitting targets for enemy gunners. The radial configuration provided the power-to-weight ratio necessary to achieve Earl's impossible speed requirements, while maintaining reliability under combat conditions. The specifications that emerged were extraordinary. Top speed projections reached 55 miles per hour compared to German tanks at 20 miles per hour, a differential that would fundamentally alter tactical engagement. The main gun evolved through multiple iterations, starting at 37mm before upgrading to 57mm, finally settling on a 76mm cannon capable of penetrating German armor at combat ranges. Operational range extended to 150 miles with 165 gallons of fuel capacity, providing strategic mobility that traditional tank destroyers couldn't match. But revolutionary concepts faced brutal challenges when confronted with engineering reality. The first T-49 prototype rolled out of Buick's experimental facility in late summer, its gleaming steel hull reflecting Earl's automotive heritage in every curve. Early test runs at General Motors' proving ground revealed transmission problems that limited speed to just 38 miles per hour. Fast by tank destroyer standards, but nowhere near Earl's vision. Critics in Washington whispered that Earl's creation was a death trap, too lightly armored and too complex for battlefield conditions. Military observers attending the initial demonstrations didn't know how to categorize Earl's machine. Traditional tank destroyer doctrine emphasized heavy armor and powerful guns deployed from hidden positions, allowing crews to survive return fire while engaging enemy armor. Earl's vehicle challenged every assumption about armored warfare, proposing speed and maneuverability as alternatives to steel thickness and defensive positioning. Conservative voices in the Ordnance Department questioned whether American crews possessed the tactical sophistication to employ such an unconventional weapon effectively. The breakthrough came during winter testing at GM's Milford Proving Ground, when the refined T-70 prototype achieved what military experts had declared impossible. 60 miles per hour, faster than modern M1 Abrams tanks would travel decades later. Earl watched from the observation tower as his creation demonstrated acceleration and handling characteristics that defied conventional understanding of armored vehicles. The vindication felt sweet but remained incomplete as larger challenges loomed. Mass production awaited. Battlefield validation would come next. Earl's design studio created the iconic Hellcat logo during this period of technical triumph, a snarling wildcat biting through tank treads accompanied by the motto, "Seek, Strike, Destroy." The symbol perfectly embodied Earl's philosophy of aggressive mobility over passive defense, capturing the predatory essence of a weapon designed to hunt rather than hide. That sleek profile glistening under the morning sun would become forever linked with American tank destroyer forces, symbolizing a radical departure from fortress-like defensive thinking toward an aggressive philosophy built on speed, surprise, and surgical precision rather than heavy armor and raw power. The summer heat of 1942 pressed down relentlessly on the General Motors Proving Ground as Earl's groundbreaking machine prepared for its defining moment. The first T-49 prototype sat silent on the test track, its graceful lines catching the early light while engineers made final tweaks to transmission systems that had caused frustration during earlier attempts. Earl stood near the vehicle he had brought to life, his fingers running along the revolutionary lines that shattered every established principle of armored design. The entire weight of American manufacturing capability seemed to rest on this single test. Proof that velocity could serve as armor, that tactics could triumph over tonnage. What followed revealed uncomfortable truths about the gap between inspired thinking and practical engineering. The transmission struggled to push the prototype beyond 38 miles per hour, respectable enough by traditional measures, but nowhere near Earl's ambitious targets. The 400-horsepower engine simply overwhelmed components borrowed from civilian applications, fracturing housings and stripping gear teeth under the punishing stress of combat-level performance. Back in Washington, doubters pointed to these setbacks as confirmation that Earl's hot rod vision was fundamentally unsound, too demanding for actual warfare, too untested for serious consideration. Overly complex for battlefield repairs, too fragile for real combat stress, too unconventional for practical use. Colonel James Morrison arrived from the Ordnance Department at Milford, accompanied by Pentagon brass, whose skepticism showed plainly in their measured note-taking and hushed exchanges. Morrison's career had been constructed on dependable, proven systems that followed established military thinking, and Earl's machine violated virtually every principle governing tank destroyer development. Morrison's line of questioning relentlessly pressed on crew safety, mechanical durability, and combat application, precisely the areas where Earl's prototype revealed troubling gaps compared to traditional alternatives. Yet Earl's engineers attacked the mechanical obstacles with fierce determination, refusing to let technical problems derail their revolutionary concept. Steve McDaniel spearheaded the drive to rebuild transmission assemblies, merging automotive mass production know-how with military specifications in unprecedented ways. His team engineered new alloys for gear components, reinforced differential casings to endure tremendous torque, and developed advanced cooling systems capable of maintaining temperatures during sustained high-speed runs. Vindication arrived in early 1943 when the enhanced T-70 model rolled onto the Milford Oval for testing. Earls watched from the tower as his machine gathered momentum, unleashing smooth power that seemed to defy every limitation built into conventional armored vehicles. The speedometer needle climbed steadily, 40, then 50, reaching past 55, finally touching 60 miles per hour on the banked curves that had previously tested only civilian road cars. This achievement transcended mere mechanical success. It proved Earl's core belief that American ingenuity could fundamentally reshape armored combat doctrine. That 60-mile-per-hour mark established the T-70 as the world's quickest tracked fighting vehicle, outpacing main battle tanks that wouldn't even exist for another generation. Earl's moment had arrived, yet success brought complications as military strategists struggled to envision combat roles for a machine operating beyond established tactical boundaries. Conventional tank-destroyer doctrine emphasized concealed waiting positions and reactive defense, but Earl's creation demanded fluid offensive maneuver, a style most American commanders struggled to comprehend. Production shifted into high gear as Buick reconfigured its Flint, Michigan manufacturing center from civilian car building into armored vehicle assembly. The transformation demanded complete redesign of factories built for elegant sedans, replacing delicate tooling with heavy-duty cranes for 20-ton vehicles and precision equipment for armor fabrication. Earl's automotive background proved invaluable as manufacturing teams borrowed mass production approaches for military purposes, developing assembly methods capable of maintaining quality while meeting unprecedented production demands. When the War Department formally adopted the design, the designation became M18. The Hellcat name achieved official status, the first time American armored forces chose a predatory name emphasizing offense rather than defense. Earl's artistic vision had reshaped not merely the machinery itself, but the entire strategic thinking surrounding American tank destroyer operations. Training programs established during this period reflected the Hellcat's fundamentally different character. Crews needed instruction in high-speed maneuvering that bore almost no resemblance to traditional tank destroyer work. Gunnery school became a challenge. Engaging moving targets at unprecedented velocity demanded timing and coordination that exceeded anything previously required in military gunnery curricula. The open turret layout that trimmed weight and enhanced visibility simultaneously created dangerous exposure, demanding novel approaches to crew positioning and survival tactics. When the first production Hellcats emerged from Buick's assembly line, Earls felt contradictory emotions, deep satisfaction alongside genuine anxiety. His audacious dream had materialized, but ultimate proof awaited in genuine combat, where American soldiers would prove or disprove his theories with their very lives. April 1943 transformed the Flint plant into an industrial powerhouse as M18 Hellcat manufacturing commenced at full capacity. Assembly lines that previously shaped luxury sedans with gleaming chrome and fine leather now thrummed with the determined pace of armored manufacturing. Earls moved through the production floor constantly, his experienced eye detecting flaws that could mean survival or death when crews encountered enemy fire. Each machine cost $55,230, roughly $746,000 in present-day terms, representing America's conviction that technological advancement could overcome enemy superiority through sheer innovation. Converting automotive facilities to military purposes demanded reinventing decades of manufacturing tradition. Powerful overhead cranes replaced the gentle equipment once used for engine installation. Their enormous arms positioned massive continental radial engines with exacting precision. Armor welding stations replaced areas where trim components previously came together. The brilliant glow of welding arcs danced across factory floors that once rang with the subdued sounds of precision automotive work. Earl's production specialists introduced mass manufacturing principles adapted for military needs, implementing quality assurance procedures ensuring each Hellcat satisfied combat demands while maintaining output speed essential for total war. McDaniel's innovation team incorporated field service improvements reflecting Earl's understanding of practical maintenance requirements. The Continental power plant sat mounted on steel rollers, enabling crews to disconnect systems, extract the entire engine transmission assembly for servicing, then reinstall everything without requiring dedicated heavy equipment. That single feature meant tank destroyer personnel could perform maintenance directly, rather than requiring depot-level facilities, dramatically enhancing operational availability compared to conventional tank destroyers needing extensive disassembly simply to access engines. The Torgant bar suspension demanded manufacturing expertise, stretching Buick's capabilities to their absolute limits. Each suspension component needed individual testing to withstand high-speed maneuvering stresses while keeping the ride smooth for accurate gunfire. These bars themselves were forged from exotic steel and heat-treated to specifications surpassing anything civilian automobile makers had previously attempted. Quality inspectors examined each piece under loads mimicking combat conditions, discarding any component showing microfractures or dimensional drift beyond microscopic limits. Manufacturing ramped toward peak output during late 1943, with Hellcats flowing off assembly lines at maximum speed. The facility ran continuous operations, 3 shifts working around the clock, employing Detroit's traditional automotive specialists, supplemented by women who had stepped into positions vacated by military conscription. Earl's design team maintained constant oversight of manufacturing, confirming every vehicle matched his aesthetic standards while meeting the brutal functional demands of armored warfare. This meticulous attention extended even to invisible details. Wiring rooted with automotive precision, controls designed with the ergonomic refinement defining Earl's civilian work. The earliest combat models reached frontline units during spring 1944 when 5 T-70 prototypes shipped toward Italy for field testing. Earls watched from the loading dock as these experimental machines were chained to railway flat cars destined for theaters far removed from controlled test environments. The prototype designation itself conveyed their provisional status. Actual battlefield conditions where American crews would test Earl's revolutionary principles against circumstances no test track could truly replicate. Specialized training developed specifically for Hellcat operators reflected the unique demands of Earl's engineering approach. Fort Hood established dedicated instruction where tank destroyer crews mastered high-speed tactical movement, bearing little resemblance to conventional armored operations. Gunnery training centered on engaging targets while racing at speeds, straining traditional fire control capabilities, demanding precision and reflexes exceeding anything in established military curricula. The exposed turret arrangement that reduced weight and improved visibility simultaneously created risks demanding innovative approaches to crew protection and battlefield positioning. By late 1943, production figures vindicated Earl's revolutionary impact on American armored capabilities. Manufacturing excellence exceeded expectations as Buick's seasoned workforce seamlessly adapted automotive processes to military production, establishing assembly methods, delivering consistent quality at record-setting production rates. Every Hellcat merged Detroit's industrial mastery with Earl's visionary design thinking, embodying America's faith in technological progress over the crude force favored by opposing armies. Earls witnessed his creations vanish into supply chains destined for European and Pacific combat zones, aware that his extraordinary achievement would soon encounter the harshest possible testing, when theory collided with genuine enemy fire and crew survival became the only measure that mattered. January 1944 brought freezing conditions to the Anzio beachhead as 3 M18 Hellcats joined the 894th Tank Destroyer Battalion's reconnaissance element. Sergeant Tommy Richardson crouched alongside his machine through pre-dawn darkness, exhaling visible breath vapor as he meticulously performed the equipment reviews that had sustained him through 24 months of armored warfare. The Hellcat's elegant contours appeared strangely foreign alongside the angular, aggressive machines dominating European conflict zones. Its streamlined proportions resembled Earl's automotive creations far more than the brutal designs of traditional military hardware. Combat introduced itself suddenly as German Panzer IVs pushed through morning mist, their commanders trusting in established armor tactics and defensive doctrine. Richardson's crew had extensively drilled Hellcat capabilities, yet theoretical knowledge crumbled when 88mm projectiles began exploding near their position. The exposed turret that Earls had crafted for weight reduction and crew visibility suddenly looked terrifyingly inadequate as metal fragments whined overhead, forcing Richardson's crew to depend entirely on speed and tactical maneuvering rather than protective steel. Richardson's combat instincts, refined across months of high-speed operational training, transformed Earl's mechanical design into practical battlefield tactics. The Hellcat's 60-mile-per-hour velocity permitted flanking movements impossible for conventional tank destroyers, sweeping around German positions with speed confusing enemy gunners accustomed to slower, more predictable opponents. The 76mm gun proved capable against Panzer IV side plating at close quarters, confirming Earl's calculated gamble, emphasizing maneuver above defensive armament. Yet incoming intelligence painted concerning complications, threatening Earl's revolutionary approach. Crews reported that the 76mm gun struggled penetrating thicker Panther and Tiger frontal armor increasingly encountered across European theaters. The Hellcat's thin protective plating, Earl's greatest calculated risk, proved inadequate against anything beyond small-caliber fire, forcing personnel to depend exclusively on positioning and velocity for endurance. The open turret configuration that appeared forward-thinking during development proved menacing in actual combat. Snipers targeted Hellcat gunners more effectively than crews manning fully protected designs, their exposed positions rendering them vulnerable to infantry weapons and artillery fragments. German commanders quickly recognized and exploited this weakness, directing concentrated rifle fire at Hellcat turrets to disrupt crew effectiveness whenever main armament couldn't penetrate the hull. Cold European winters compounded tactical struggles as Earl's automobile-derived systems encountered environmental extremes exceeding design specifications. The engine cooling arrangement that performed admirably in mild climates turned personnel compartments into iceboxes during brutal continental winters. Crews complained the exposed turret, paired with inadequate heating arrangements, produced working conditions bordering on torture during prolonged combat operations. Mechanical durability that appeared so carefully engineered during development deteriorated under battlefield stresses exceeding anything encountered at proving grounds. Richardson's combat reports painted a complicated portrait of Earl's machine in genuine warfare. The Hellcat's acceleration and maneuvering capability proved crucial for reconnaissance operations and sudden assault tactics beyond conventional tank destroyer capacity, yet serious combat against heavily protected opponents exposed fundamental limitations in Earl's design philosophy. Most crews preferred the M10 Wolverine's heavier protection for defensive situations where armor advantage superseded mobility benefits. Psychological stress accumulated as personnel training emphasized velocity and positioning rather than protective steel. Richardson's crews discovered that transitioning from automobile-inspired engineering thinking to battlefield existence proved harder than anticipated. Persistent consciousness of vulnerability created psychological strain surpassing that experienced by crews operating inside thicker-hulled machines that, while potentially no safer, at least provided mental comfort. German intelligence analyzed the Hellcat with grudging respect despite recognizing its constraints. Wehrmacht strategists appreciated the American machine's remarkable velocity and tactical flexibility, developing specific responses emphasizing concentrated firepower and coordinated ground troops to exploit open turret exposure. German combat doctrine shifted to treat Hellcat encounters as critical threats requiring immediate suppression because of their troubling capacity to materialize unexpectedly in flanking positions. As summer 1944 progressed, operational commanders questioned whether Earl's entire design philosophy remained sound. Certain units requested Hellcat replacements, demanding more heavily armored equipment and pointing to personnel losses and mechanical failures that seemed to outweigh velocity advantages. Earl's lifelong reputation, built on automotive achievement, faced its sternest examination as battlefield reports suggested his audacious gamble might have sacrificed American soldiers rather than protecting them. Troubling assessments accumulated in Detroit as Earls grappled with the possibility that his revolutionary vision had ultimately failed its most significant test.